Oh, yeah. Okay, guys. Good morning, good afternoon, good evening. This is Muhammad, uh, a small boy. Uh, I'm making this video for all of us. You get so this is like a preparation for the coming exam. Since a lot of people not like messaging, like we need to come up and you know to make this exam. So instead of now coming to school, just taking one person each time and all, so we are making a video. And this video, one of the advantages is you'll be able to come back to it later and rewatch anything you missed and all. You get me? And one of the benefit of making this video is I've also learned a lot from it. So let's get started. Nothing to like, no bush, no beating around the bush. So let's get started. Now, the star one is our course outline is there is presentation and representation of data, there is fitting of probability distribution. So I think we treated three distributions: binomial, normal, and then Poisson. Then we have the goodness of fit. The fourth one, designing of questionnaire and contribution of sample number. I don't think we have reached it, but this is kind of easy. You can get it online. And use of random numbers table and some statistical table. Even Korean. Oh yeah. So yeah. So these three, these five, I think we only have two that make sense, that is very hard. The main content of this course is two: fitting of the probability distribution and then goodness of it. That's the main content of this course. Then presentation and representation of data, we have treated it in first semester as when you show your data as histograms, pie chart, bar charts, or we use those one for we have one for qualitative data and quantitative data. We have histogram, bar charts, pie charts. No, we have a lot, so you can just go through it again. That's not the main thing. I'm not sure the man even treated it in his notes. Now, but let's go straight to this fitting of binomial, abi probability distribution and goodness of it. So you see here, I said how to see number two and three. The number two and third section as just one section. In my head, and as my colleague, I want you to treat these two sections as just one. Since this is the main content of this course and it is based on making inference on two group of data, at the end of the day, we are going to use fitting of distribution for group of data. They already performed statistics on the main and the individual data. When you are dealing with all these things, they will give you individual data, they will give you the group of the data, and they will give you the frequency for each data in that group. Do you understand? So it is more like something like this. I'm trying to make an example. Then frequencies. You see, they will give you each data in this number of it. So it says when we run it the first time, maybe we get two. I mean, when we run it two times or something, we get two. When we run it again, we get four, five, six, seven. Then in frequency, you can have two, three, four. So this is how it is going to be normally. You see, it is a group of data. We have category. This is one, two, three, four, five. It is five categories. The frequency will be there. So most time it is grouped of data. This is grouped. Do you understand? Yeah, we have the frequency and we have the number of headers and everything. Or two group of data. There will be one data at the top. It can be different in number of girls, number of guys, sometimes not frequency, but I don't want to go that way. I'm trying to keep this thing in the scope of what the lecturer taught us and all. Yeah, so I don't want to like go out of the way and you will be confused. So now you see these two as the same thing, the number two section and the number three section, see it as as one thing. Do you understand me? I'm sorry. He said the step of fitting a probability distribution will always end in getting the expected frequency for the data in the group. When we said we have each data, I'm not sure if I have the notes. Let me get the note of that man. Ah, this man talk say test is on Sunday. How now? How you go put test for Sunday? I'm trying to get the file of some notes. They I don't have it again. So, but in the note, if you go through the note again, you should see what I'm talking about. But I think I should pause this video and get the note so everything can be clear. Yeah, yeah, yeah. So I saw an example now. So I think this is the same. This man used the same example in our notes. You can see a set of three similar coins are tossed 100 times in the following results. So what this means is this frequency will always be equals to 100. So that's the big N. I'm just trying to give you an example. So this is how it is. There's two category of data. There's number of heads and there's frequency. In this number of heads, we use the frequency to find the expected frequency for each data. This is 0, 1, 2, 3. We find the expected frequency for that. Then we compare that expected frequency to this frequency that we were given. That's the observed frequency. So that's what we are doing entirely. Everything we are doing is just comparing two set of data to each other and making inference if there is any relationship between them, if it is correct or there is no correction, or it is not correct. So are they relating in any way? Are they not relate? The frequency that we get here, I mean everything we get here, it really representing this data that we were given? So that's everything we are doing. We are just making the inference if this data we are working on is really representing. So now if you're given this type of data, the step of fitting a probability distribution will always end in getting the expected frequency for the data in the group. When they say you should fit a probability distribution, what are you doing? You are just getting expected frequency for each of this thing this thing here. They give us one frequency, that's the observed. Then you will get expected frequency for each of the data here. So that's what we are doing. After getting the expected frequency for each data, then we compare it. We use goodness of fit and maybe chi-squared or something and use it. But in our tutorial, we are going to use the chi-squared. So that's what the lecturer used. Now, on the eye level, so I said on the eye level, on a normal day, on eye level, fitting of probability distribution is always the same step. No matter what kind of probability distribution you are given, you will always follow the same step. The only change, the only change we experience, will be based on the type of probability we are dealing with. We'll be skipping the detailed explanation of types of probability distribution since this tutorial is based on the common examination, but we'll be including some YouTube links for anyone interested. So this I will send this file. You can see all this YouTube link to explain more on each probability distribution, what binomial distribution is, and what's it called? What normal distribution is and what Poisson distribution is. Let me just explain briefly. Binomial distribution just mean, if you remember in one class the man was telling us, it means we are dealing with something of failure and success. When you perform an event, in probability everything is an event. So the event will only have two outcome. We have one of the two outcome. It's either it is a success or a failure. It is a head or a tail. You understand? So when you have that kind of thing, binomial, that's binomial. It is binomial. We have those two outcomes. So there are other rules that we must follow for it to be binomial. So there will be ends of trial, and we will have the same probability for each event, and they are independent of each other. They are not depending on each other. Do you understand? Now we have normal also. Normal is the normal distribution. When you see a question that said normally distributed, it is normal distribution, and this is a, I think this is a continuous distribution. It can be point something, but binomial and Poisson, they are discrete. You get me? When we said it must be one of the outcome, you can't have 1.5, you can't have 1.2, but in normal you can have 1 point something as the outcome. And then this Poisson here, it is also a discrete, but Poisson deal with time interval, something with time interval. When we said we have two male coming in every 5 hours, or we have two students coming in every two days. When you see something like every 2 days, per day, per month, per something, that's Poisson. Yeah. So let's go. So now, steps to fit a probability distribution. When you are given a question and it is based on probability distribution, so I'll be telling you, when you are given a question in the exam, or in the test or anything, the only the steps is always the same. You are following the same steps for all distributions. Don't be disturbing yourself. Say what's the formula for chemical for at first. That's not what you should think about. There are some things you should just do first. Then after getting to the point of finding what formula you should use, then that will make your work easier and make the abstraction more easier. So you won't be worrying about some things you shouldn't worry about at first. So your exam will be fast. So the only difference is how to find the cumulative probability for each data. So that's the only difference. The way you find cumulative probability for a normal distribution is different from the way you find for the Poisson, and it is different from how you find the binomial. So that's the only difference. The only difference. So we have 4 steps. What are the 4 steps? Number one, find the mean and standard deviation for the given data if not given. So most questions, the lecturer will already give you the mean, that's the mean, and the standard deviation, and that's the sigma for each of the given data. No, for the given data, not each. For all given data. Do you understand? Since we mostly be dealing with group data, so it is a group data, so you will be using this formula. They will give you the frequency already. Do you understand? They will give you the frequencies. So what you just need is find each x. This is it here. Represent x for each data. So if you are just giving x, like here, we are not giving the number of x is 0, 1, 2, 3. So our x in our table will be 0, 1, 2, 3. But if you are giving like a group data, from when they said from 0 to 10, from 10 to 20, you can use the lower bound value for the group data. I hope you understand what I'm saying. So this is what I'm saying. So the one we see now, it says norm of x 0. So I'm trying to like calm down here and explain everything. So this is what we are basing on: 0, 1, 2, 3. You see now, if you are making our table or doing our table, when we say x, you will say xi, right? Then you will make a line, then you say what? The frequency of that x, fi. Then so this is what I'm trying to do for people that doesn't understand. This is it here. This is it here. So this is the table here. This table. That's what I'm saying. And then you do fx also. That's f times x. So for this number of now for the x is here, you just use 0, 1, 2, 3. But what we are given a data of norm of x. So when they give us the norm of x, they just say 0 to 5, 0 to 5 for the first one, 5 to 6 for the second one, no, 5 to 10 for the second one, then 10 to 15 for the third one, and 15 to 20 for the fourth one. If you are making this table now, our xi will be equals to, we can use you can use anything based on you, but says we should use lower bound. But make sure anything you are using is the same for all. So you can decide to do 0 plus 5 divided by 2, or just use how the lecturer said. He said you will use 0 here, that's the lower bound. You use 5 here for the second one. I mean, this second one you use 5. This third one you use 10, that's the lower bound. And the third one you use 15. 1 2 3 4, then 1 2 3 4. So that's how you'll be using it. Based on anything, you find your x6 for your table. So after doing the x for your table, let's move forward. Then you find the mean and standard deviation for the given data if not given. So in the question, the lecturer can decide to give you your, you get me, he can decide to give you your mean and the standard deviation. They use x bar here as the mean. You can use x bar, you can use mean. I use mean because we are already familiar with mean, and we are dealing with population here, so I think it is the same thing. So now, when you want to find your mean, this is the formula you'll be using. The formula here, you'll be using it for your mean, and the second one you will use it for your standard deviation. So for the first thing you do is, you already find your x here, you find your f here, then you will now create a table for your fx. That's the f times x, the frequency times the x. So it says 0 times 36 here. We are trying to solve this question. We make this table. 0 times 36 here, we get 0. 1 times 40, we get 40. 2 times 22, we get 44. 3 times 2, we get 3 times 2 is 6. I think this they made a mistake here, so we should know 3 times 2 is 6. Let's plus it. If we plus what they post here, it will be more than 44 plus 40 plus 6. That's 90. But if you use the one that they use here, it will not be 90. So you should know what you are doing. So our fx, let's make our fx table here. So we can make our fx table here to be what? Our fx table 0, 40, based on what we are getting here, 44, then 6. This is it, 3 times 2. Shall you get me? This is 6, not 44. So if we plus everything together, what's the formula? The formula says sum of all fx. Do you get? Sum of all fx. You remember, as a statistics student, this is summation. That's the summation symbol. Then fx is f times x. So sum of all fx. Let me just write all table here instead of going to that place. I will copy this. This is our x. What's our x? 0 1 2 3. 0 1 2 3. And our f is what? 36 40 36. It just means we get 0 36 times, we get 1 40 times, we get 2 how many times? 44. Then the next one is what? 2. No, I think I made a mistake. 36 40 22 2. 36 40, this is 22, and then this is what? 2. Now we need what? Our fx. That's the f times x. So 0 times 36 is what? 0. 1 times 40 is what? 40. 2 times 22 is 44. And then 3 times 2 is what? 6. So what next do we need? What we need is just add efx. So from this table, right, we can get our sum of all fx and sum of all f. Remember, what do we need in this formula? It says the mean equals to the sum of all fx and the sum of all f. So let's do that. fx, it will be 0 0. Okay, let me write it out. Let's use capital letter E for our symbol here. That's not the real symbol, but I'm just using it here. Equals to what? 0 plus 44 plus 40 plus 44 plus 6, which is equals to what? 44 plus 40 plus 6 equals to 90. Then the sum of all f equals to what? 36 plus 40 plus 22 plus 2, which is equals to what? You can use your calculator. 6 plus 40 plus 22 plus 2, 100. So that's 100. Now they said our meal, let's use capital letter U for that, will be equals to the sum of all fx divided by the sum of all f, which is equals to 90 divided by 100, which is equals to what? 90 divided by 100 equals to 0.9. So our mean for this table is 0.9. The first step is to find our mean, our standard deviation. Now let's find our standard deviation. This will be a long one, man. But so coming, I don't want to use this step that this man used it. This is the same step that our lecturer used. Or should we use it? But I feel all these things, they will just be introducing new formula. Something you can just use your table for every time you are doing it. I think one of the advantages for this thing is now I don't want to use it. Let's just use it the normal way. And if you now decide to use this one as the lecturer do also, you can now come back to it. This is also easy, but I feel explaining may not be straightforward. So he's not using the standard deviation. He's not using the standard deviation here because they are not finding the z score. They did not find the z score here. Okay, this is for binomial. Sorry. This is for binomial, not normal distribution. Okay, we are not there yet, so we are just doing this one generally. So now it remains the standard deviation. If you remember last semester on our in our one of our tutorial, instead of doing this one, it will take time. Just use your calculator. I just remember now, sef. If you remember last semester where the guy teach us how to like get, do you remember how to get where you enter your calculator, you click on mode start, then you click on the, I think, is it a plus bx that day? Yeah, and then you input all your x data and then all your frequency data. I don't think, I feel everybody remembers this trick. uh hmm, I'm trying to like know how to show it on the PC now. I'm coming. Okay, so since we are dealing on exam, so you need your time, you need every time you need, instead of doing all this one we are doing here since morning. Although you can table the data like this, but instead of finding all this manually like this, you can use your calculator. So I will make another video on how to use calculator although we already used it last semester, but if you don't remember again, I'll make a video. Put your x as 0, 1, 2, and then 3. Then go to the second one, put the 36 as your y. So 3 is what? Is 6. 2 is 44. 0 is 36, and then 1 is 40. So I'm trying to input it in my calculator. Then you click on AC, you click on shift and 1, then your data, yes, make sure it is there, then shift 1, your variables, and you can see the X bar as your mean. Click on 2. Comment. Oh, I think I input the wrong data. 36, 40. Okay, the second one is 22. This one is 22. Then the last one is 2. So then 1 your data, 2, then no, 1 your variables, then your mean, which is equal to. So like I said, I'll make another video on how to use your calculator to find all these things. So after using the calculator, our mean equals to, the symbols in real life, 0.9, and our standard deviation SD equals to, you can see it here. So after a lot of Google searching and YouTubing, so I found how to do this very well. And yeah, I will make another video on how to do it, inshallah, and post it here. So it will make it easy for us when we are writing exam. So the frequency are what? 36, 40, 22, and then 2. So AC, shift 1, the data, okay, correct, shift 1, the variables, we need the 2, which is equals to 0.9, very correct. Then we need this SD, shift 1, 4. We need the standard deviation for the population, so I think we will use the 3. 0.8. So let's confirm if it is. How will you confirm if it is correct safe? So we will just use it. I feel for this one to be correct, for the standard deviation, the mean to be correct, the second one will be correct also. So even 0.8 now, you know, now you don't need any all this formula sef. For the number one, you don't need the formula. If you have this calculator, you are fine, you are good to go. But if you don't have calculator, so now in our table, we have the mean, we have the standard deviation, we have our x for each. What is the next one? Find the expected frequency for each data. Find the expected frequency for each data. That's the next step. So that's the step that is different for each probability distribution. It is different from normal, it is different from the binomial, and it is different from for the Poisson. Yeah, so we'll just be treating each one for the type of the distribution we are working on. Then the next one is now to table the expected frequency against the observed frequency. When you get your answer for each of these things, so you make another table here, and call it E. So you get, this is the expected frequency. You now get each one for this, each one for this data, each one. we have not do it, so we are putting 0 for now. 0. You will now make another table. Do you get me? So the table will look something like this: the expected frequency and your frequency that you were given, the observed frequency. Shey you see now? So the expected frequency, we have not do it, so we put 0 for everything. Now the frequency we were given, what's the frequency? That's 36 40 22 2. 36 40 22 2. Then from this 2, now this 2 you go come use chi-square on and make your inference. So that's everything about goodness of fit and chi-square. Do you understand? Here we skip this thing, find the expected frequency for each data. So how are we going to find the expected frequency? Now let's see this question. In the question it says, when a binomial, okay, he said a set of similar coins are tossed 100 times with the following result: fit a binomial distribution and estimate the expected frequency. So the question already tell you the type of frequency the type of probability you are working on. If they give you the type of probability, or you find it out yourself. So now the next step is what to do when you have the type of probability you are working on. Now let's copy this. you know we treated 3 in the class. Now we are going to treat the 3 now. So now, how do you find expected frequency for a binomial distribution? How do you find it? So that's it. We said other steps are the same for all of them, but when your question is a binomial distribution, how do you find the distribution? Now first, you write the PDF. Is this PMF or PDF? Probability function, I don't know. I think, okay, density is for continuous. Yeah, I'm not sure, but it should be PMF. Is it PMF or PDF? Wait, let me confirm. Okay, I think it is PDF. Yeah, yeah. Density function for the discrete one and mass function for continuous one. So the PDF for this function equals to, if you remember, should I write equation instead? Wait, I'm coming. Let me write the equation out here. Sorry. So, oh, let's use this. So let's use C. NCR. No, small letter R. No, X. We use X for this one. NCR then times what? P. P raised power what? Raised power the X. The next one, Q raised power N minus X. If you remember, that's the formula for this. So this is the PDF formula. I think this one is clear like this. That's NCX times P raised power X times Q raised power N minus X. So that's the PDF. Now, if you are now finding uh, combinative frequency for each of them, you can use the table. There's this table where you can use it to find the X directly. You don't even need all this formula when you go to the table. So I don't know. I prefer the formula personally because I just press everything fast fast. But let's go find the table. We are dealing with binomial distribution now. So let's go for binomial distribution table. I'm just finding it online for now. So we can print it. If you think the table is fine for you, instead of using calculator or anything, you can just use the table directly. You see here, the table is very long. So now, if you want to use the table, first you need the n and you need the x. You need your n and you need your x. The n is the number of trial, and the x is the one when you are trying for. So this is our x is here. Our x is this is it here. Let's go find this. Let's go find this. So you can see. Okay, our n is the set of maybe they can say a set of three similar coins, a kini coin of five kini coin or something. That's our n. If you remember, there was a question in our class that said a five families were taken in random. That's our n. Do you understand? That's our n. That's the number of trials that we made. Three is the set of coin we are working on here. So you find your n after getting the PDF. If you don't want to use the PDF, I'm trying to use a very simple logic. So n equals to, don't give me kini now. N equals to what? 3. When n equals to 3, so we need our x. X is here already. So we are finding for each, we are finding this expected for each of these data. So let's say our x equals to 0 or x equals to 1. So let's find for this one 3. Let's find for this 3. We are finding the value here. So our x equals to 3, our n equals to 3, our x equals to 3 or equals to 2. You can use anyone. So our x equals to 2. So we are finding for the second one with that. So and our x equals to 2. Let's come to this table. He said when n, what is our n? This is our n equals to 3. And our x equals to what? Our x equals to 2. And then what is our p? Then we need our p to use this table. So if you remember in the formula, when you are finding binomial distribution, you need your p. And p equals to what? It's a small letter p now. I think everybody understand. Our p equals to the mean divided by the number of the set. Our mean divided by the number. Do you remember? So this is the formula here. P equals to x bar over n. Do you understand? X bar over small n. That small n will be our 3. That's the set of this is our n here, and we say the p equals to mean divided by n. We find our mean, that's why we said we must find our mean. We find our mean here to be 0.9. So what's our p? Our p will be equals to 0.9 divided by 3. So p equals to 0.9 divided by 3, which is equals to 0.3. So we have our p. Our p equals to 0.3, our n equals to 3, and our x is 2. Just use this table with all this data. So you come here, he said when n equals to 3, so when n equals to 2, when n equals to 3, this is the 3 here, and our x equals to what? Our x equals to 2 here. You see, I think this is for 0. They did not just write it. This is 0 tab here at the top, and this is 1, 2, 3. So when our n is equals to 3 and our x equals to 2 here, and the probability is what? We get 0.3 that time, and our probability is 0.3. So our answer will be equals to 0.189 for that x. 0.189 for that x. Let's go find it. Let's go see if it is correct here. Okay, this formula is not using this step. You can see now it is different step. So we find the the binomial distribution. We find the binomial probability for that x. You get now. So when we find it, we said you can use this f of x. This PDF is f of x. So instead of using this formula every time, you can just use the table. Now you now say f of, what do we use? F of 2 will be equals to what we get in this table, 0.1890. See, so let me come again. So you will not be like confused. We don't need this PDF again. We can delete it. We are using table. Let's use the table. I think it is fast and it is straightforward, and it will save you a lot of time on that day. So I feel that's what we should use. I'm coming. So when you are using binomial distribution, remember you will be working with p and q. So in case you need your q equals to p minus 1 minus p. Don't forget. So all these things are just formula. So to keep, so they are just formula to remember. P is mean over n, and then the q is 1 minus q. We already get our n equals to 3. They give us in the question. We are working on x, and x equals to 2 here. We want to find the expected frequency for x equals to 2 here. Let's just find it for everything. So we will do this example like completely. So x equals to 0 instead. X equals to 0. Now let's find our p. After you get your table and you get your data, you are finding the expected frequency, and we are working on a binomial distribution, right? In binomial distribution, p equals to mean over n, the q equals to 1 minus p, they give us the n, which is equals to 3. We are working on our x, that is equals to 0. So now our p, they said this is the mean over n. Our mean is 0.9 and our n is equals to 3, which is equals to 0.3. Let's just put our q also. So our q equals to what? I don't know why this thing is doing like this. So our q is 1 minus 0.3, which is equals to 0.7. You get it? So we have all our data. And we said we can use the table. And now let's use the table to find when f is 0. You get now? So what is our n? Let's go to the table. Our n is, I will print this table out so in case we want to use it. So our n is what? Our n is 3. Our x is 0 here. So you did not write the 0. So, and our probability is 0.3. That's our p. Let's come here. So it will be 0.3430. 0.343. Let's write it. 0.343. So when f equals to 1, So after getting 0 point, where is it here? 0.340, you will just come down when n is equals to 1, which is 0.441. So when f equals to 2, we already get that one. 0. See, this is it here. Okay. Then our 3 is 0.027. So after getting this thing, how do we now get our expected frequency from each? We get our function of x for each of these guys, for each of our x's. How do we get our expected frequency from this? What you just do is all this data, you just times it by the big N. So our expected frequency equals to big N times the function of that x. So you can ask, what is big N? So big N is just the total sum of our frequency. So big N equals to sum of all f. That's our N, big N, not small n. The small n is the number of trial we did. That's the 3. And then our big N. So when you have two ends, most time the big N will be the biggest. So if you don't remember well, just remember this. When you have 2n, the big N will be the biggest out of it. That's the number of total frequency. The number of total frequency. Now, what is our big N? What's the total frequency? Let's go back to our table. Our total frequency we did that time is what? Is 100. So you will just sum everything here. 0 plus 40 plus 44 plus 6. This is it. No, this one. 36 plus 40 plus 22 plus 2, which is equals to 100. In the question, I'm not sure if they can give you in the question and they may not give you. So just know the sum of all of your f is equals to your big N. That's 100. So all our data that we get here, this f0, so we will now be finding expected frequency of that 0 equals to 100 times this one that we get here, times this that we get here, which is equals to times 0.343, which is equals to what? We can just go and confirm this if what we did is correct. 0.343, 34.3. Ṣáà ti gbé gbági báyìí. When you call on me, I go show. Anytime you need help from me, let me know. You see, it is correct. 34.3, this is it here. Do it for the second one. Let's go. Then when it is 1 equals to 100 times 0.441, which is equals to what? I think that's 44.1. This is what? 34.3. When it is 2, times it by 100 times 0.1890, which is equals to 100 times 0.180 is equals to what? I think 18, Connie. Yeah, 18.9. You see, when we approximate it will be 19. Okay, 100 times 0. What? 027. What's that? Is that not 2? Which is equals to 2.7. Do you get it now? So you can see, but we cannot use all this. You remember when I talked about discrete that time? Binomial is a discrete probability. It cannot be in point. So you will approximate all of this to the nearest whole number. This is 34. because 3 will become 0, 44. 9 will become 1, so this is 19. And then 2.3 will become 3. So let's confirm if it is correct with the. So you can see 34, 44, 19, 3. What do we get here? 34, 44, 19, 3. So let's go and update our data here. So we will update our data. Where do we create that data? I think we created the data somewhere. That we use 0. You can see here. You can just update it to what we just get now. So what do we get? We get 34, 44, 19, 3. So this is our table. 34, 44, sorry, 44, 19. Then this one is 3. You can see. So it just means when our x is 0, our expected frequency is 34. When our x is 1, our expected frequency is 44. 2, it is 19. 3, it is 3. So that's how it is. You get your expected frequency from this. Then the next thing is to do what? If you remember, I said table the expected frequency against the observed frequency, then use your goodness of fit to calculate the, use maybe a chi-square or something to calculate the goodness of fit. So I'm not sure we are going to treat goodness of fit for now. I will make another video on goodness of fit. I want us to do uh, another example on what's it called. I'm trying to. So this is 51 minutes already, so we can still go on. So let's do another example that will be straightforward. Everything we are doing now will be straightforward now. So let's go online and find a question. So let's come here. I'm not sure this is the type of way the lecturer is setting the question. Let me use ChatGPT. Oh, sorry. It is not binomial. Fitting of binomial distribution. Oh, abalajo. See, okay, ChatGPT give us a question. So let's see if this will place the question. Ṣé kò ti wá gùn jù báyìí? I think it is too big. Let's make it smaller so we can see it well. Yeah, the lecturer can ask question like this. Mhm. So we can see it well. Let me go and use a board to like solve this question so it can be easy for us. So this is the last thing we are doing on binomial distribution. So what is the question? So the question, let's come to our board. Let's use board instead of that one we are using. So okay, the scenario is said a quality control inspector at a manufacturing plant checks a random sample of ten items each day for defects. Over the past 30 days, the number of the defective items found each day is recorded as follows. So let's see our table. We have our table. So it said number of defects and the frequency. So this is everything here. We know it is a binomial distribution. How? It is either there's a defect or there is no defect. So do you get it now? So it says when we have zero number of defects, we have a frequency of 5. In our last what's it called? In our last example, what you will do, the first step you will do is take your calculator and input this data inside it. So I'll take the calculator now, go to shift mode, then go to mode number 3, then go to number 1. And if you are following this step, you can take your calculator. If you are using FX 991 ES plus, before doing this, go to mode, press on 3, then press on 1, click on or AC, then click on shift, press on mode, press down button, go to number 4, and then click on number 1. Follow this step, and then if you don't understand, I will make another video, don't worry, but just know that you will use your calculator here. So first, go and watch the video on how to use the calculator, then follow it. Click on mode, go to number 3, then click on number 1. Now input all of this number of defects. Number 1 is 0, 1, 2, 3, 4, 5, 6, 7, okay, 8, 9, 10. You see, this is 11 data. Now let's go back up again. So when it is 0, it is 5. When it is 1, it is 8, 7, 4, 3, 2, 1, 0, 0, 0, 0, 0. Now click on AC, click on shift, click on number 1, the variable, then click on number 2 to get your mean. The mean is 1.93. So we have our mean here. We don't need to like do all those calculation or anything. Just click on, put it here. The mean is x equals to x bar. Remember, it is x bar. Now because say I no get option, now why I use it. This is x bar, something like this. X bar equals to, what did I call it, 1.93. So that's our x bar. So what's our standard deviation? Even though we will not be needing standard deviation in binomial, but we will still find it and know we already get it. So the SD equals to standard deviation, go to shift 1, 4, and then click on 3. So it is 1.46. So we have this already. So we have this. What is the next step? If you remember, we have our standard deviation, we have all our x's. This is our x's here, 0, 1, 2, 3. This is our frequency. We don't need to table the fx, and because we already get our mean and our standard deviation, and we are dealing with what? We are dealing with binomial distribution. What do you find next? You find your p. So what's our p? We said our p equals to n x bar divided by the n. So you see, now what is our n? What's our n here? Okay, our n. The question says checks a random sample of 10 items each day. 10 items each day. So that's the number of trial. 10 items. So our n equals to 10. So our n equals to 10 and our p is x bar over n. So what's our p now? We can now say our p, that's the probability that this thing will occur. That's what p means. P equals to the x bar, which is 1 minus 1.93 divided by our n, which is 10. So what should that give us? Which is equals to 0.193. So that should be our p. 0.193. Sorry, 1.93 divided by 10. 0.193. So we have our p. The next thing, we find our q. If you remember, we find our q. And q equals to 1 minus p, which is equals to 1 minus 0.193, which is equals to what? 1 minus 0.193 equals to 0.807. See, so we have all the data we need. We have our p, we have our. What is the next step? We find the probability for this, for each data here. You can see 0 to 10. We find it, our n is 10. We find it on our table. We find the 0 to 10 on our table. So here, I'm trying to like paste this kind of thing. So since we can't paste it there, let's just create our expected table here. You see, so we can say our expected frequency. You see this table, we are just continuing it. So this is our expected frequency, which is denoted as what? As E. You can see, as simple as this question is, we are not beating around the bush. We are just going straight to the point. When we are given the question, we find our x bar, we find our with the calculator, we find our standard deviation, we find our n, we find our p, we find our q. So the next thing now is, let's find each expected frequency for each data. To do that, we need the function of x, the probability of x for that, for each data too. Do you remember? Or should we like, let's create another table. Instead of doing it directly, let's create another table here. So this is what we do. Wait. So after getting this data like this, you see, now we will be creating two data also, right? So we create another table. This is the fx, the f, the function of x, which is just the probability of x, p of, if you remember, x equals to x, and it has its own formula. I think that's when we said npc, something like that. Like I said, you can ignore this thing, you can ignore it. I'm just trying to make the table familiar with what the lecturer has taught us. So I think this is good. So you can calculate it with calculator, but we are not using calculator here. So let's find our function of x here. Let's find our function of x. How do we do that? This will be our expected frequency. I mean, see, I will call e of x. So e of e, let's just use e. Now, if you remember our x still dey here, let's our x is all this and this is our frequency here. Remember, we have not changed this data now because say we copy am e dey there. Let me remove it sef. Now, so when our x, what is the first x? When our x equals to 0. So let's find our function of x. So let's go to the table. Remember, you will go to the table. What's our n? Our n is 10. So we will scroll down here. You see, our n is what? 10. So this is where n is equals to 10. So we will come to this page. So when the n is 10, what are we doing next? So when our n is 10, what is our p? So our p is 0.19. So our p is 0.19. Oh, so 0.19 approximately is 0.2. So we will be using this 0.2. Do you understand now? So let's go to 0.2. So we know we are dealing with something here. So it is around there. You can see here. So what is our x? So first we said our x is 0 for the first one. When our x is 0, so this is the first one. We can comot for this page now. So this is our 10 and this is our x is 0. So our value is 0.1074. So instead of using calculator, we can just be using this. So when our x, let's write the formula here. This one is n times function of what we get in function of x. Shey you remember? So 0.1074. When it is 1, nko, you know this is 0, so 1 will be the next one. 0.2634. Sorry, 0.2684. When it is 2, so the next one 0. So we can be moving down like that. So let's just be highlighting this. So and if we gbagbe line one, this is 0.220. So move to the next one. 012. Okay, 012. Let's go to 3. 3, then to 4. We can just be doing it till we reach 10. 4. You can see as easy as this gets. If to say we dey use calculator, kò ní easy by 5, 6. Oh sorry, Yoruba people, no be only Yoruba people dey here. So but it is fine. 7. 8. You can see 9 and 10 is just 0, 0. I think it is infinity. That's why they don't write anything. So you can see then. So the next one here is to table our data here. I think maybe it will grow up there. So let's just do it one by one. Why is this thing doing this? I'm just trying to make this table presentable, Jare. Okay, I think it is fine like this. Now we will change it for each data. So when our function of x is 1074, what is our expected frequency? I said when you are finding expected frequency, what will you do? So let's come back here. So to find your expected frequency, that big E, it will be equals to the big E equals to the big N times what you get in function of your x. What you get here. So that's how you find it. So what is our big N? Remember I told you our big N is the sum of all the frequencies. So this is where the frequency is useful. You can use your calculator to get it. So sum of everything here. So let's go to the calculator and see if we can get it. One, the variable. Okay, the sum. It is just bringing x square, not the frequency. It is bringing just sum of x. So let's sum it as a 5 plus 8 plus 7 plus 4 plus 3 plus 2 plus 1. Every other thing is 0. That's 30. So let's see how ChatGPT. So yeah, 30. That's correct. So ChatGPT also use 30. You get me? So even the way ChatGPT calculated the P, they are using another option here, total defects over total item, and they get 0.27. And we use another formula, we get what? 1.93. And at the end of the day, we approximate it to what? We approximated it to 2, and we use 2. Now 0. So we use, sorry, I'm talking of P, 0.193 abi. With this is what we use, and we approximated it to 0.2. And the one ChatGPT do also, it was approximated to what? 0.2. And we are using the table. Now let's find for what. So it did not even help you, it just give you how to do it. Now we actually verified our big N is 30. When you sum the all of the frequency, it is 30. Even it is also in the question that over the past 30 days, but just make sure you sum all your frequency together. We said our N is the sum of all frequency. That means the sum of everything here. The sum of everything here. That's our F. That's our big N. So for all question, for all the question, that's a N. Even if it is normal distribution, if it is binomial, if it is Poisson, the sum of all the frequencies is your N. So we said the E will be equals to what? The E will be equals to 30 times fx. See now. So now everything we get in that fx, we will just be timesing it by 30. So this is what I'm saying. So everything we get here, we times it by 30 to get our answer here. And this is our final answer for fitting. Then the next step is going for chi-square or anything. That's how fitting is done. So let's times everything by 30. 0.1074 3.22. So 0.2684 times 30 is 8.052. The third one 0.3020 times 30 is 9.06. Remember, we go still approximate all these things, so you go just dey write 9 all the whole numbers. 0.2013 times 30. Let me pause this video so I can make this thing fast. 6.039. I want to pause it and do everything, so we no go dey use after doing everything. This is our final answers that I got. So you will table it, then you will now table the expected frequency that we get here, the expected frequency over the frequency that they give us. You can see the frequency that they give us. You will table the same thing, you will table the data together. Do you understand? Then you will now perform your chi-square. So let's move on and go to what's it called? Normal distribution. Like I said, this thing, they are same steps. So let me pause it, and I don't want this video to be too long. If you can see, we already answered all the question that ChatGPT. I did not even remember, but following that step, we already answer it. Proportion of defective item, that's the P, we find it. Binomial distribution, we did it. Expected frequency, we also did it. So now let's come here and say find the expected frequency. We are just finding the expected frequency for different type of data. So now let's say we are working with normal distribution, and this normal distribution, I want to use the the example that the lecturer gave us. I'm not sure if I will see it. So let's find one example to work on. So normal distribution, and so we will talk about how to find its data. Let's find the question. I'm coming. Let's now. So I'm showing you the lecturer note now. If you go look at this lecturer note that we have in the class, you can see all these things, they are the same. You calculate the mean and median, you find the xi, that is the lower bound, or you use the normal x. But now, the next step now after doing that two things is to find the expected frequency. This is the last one here. But the step to find it in normal distribution will be different. So this is the step that is different. So this is how I'm going to do it. In normal distribution, using this lecturer text, we will now form our own using tables instead of using calculator or anything every time. Using tables, we are going to be using tables. Now let's go ahead. I will write the step out, and then we move forward. Okay, so I wrote out the step to find normal distribution, to find the expected frequency for normal distribution. We already have our mean and the standard deviation. And the next step is to find the z, sorry, we call it the z score for each of that x. After finding the z score, you find the cumulative probability of that z score. Then after finding that one, you find the change in the z. Then the next step, you multiply that change in z by n. So how do we do that? That's what we are going to show in the video. So we are going to show the steps on how to do that. So let's go back to our board. Now, so I was trying to get one question from ChatGPT. Okay, that was for the last one. Now let's come here. Actually, we should be using we can delete all this, we should be using the example that the lecturer gave us in the class, so it will be easy. You will be familiar with it. So the first step, we should find z score. So yeah, so the thing is, I will be cutting this video. I will make this one as a general, and this one will stand for binomial distribution. So I will make another video on the normal distribution and another video on Poisson distribution. So this will be organized. I think the video is getting too long. The binomial and the normal and the poison should not be that long. So I'll make another video next. I will cut this one right now, make another video and put it in a playlist so you can watch it differently. You get me? Yeah. Bye.